All right, welcome everybody. We are getting started with solving and graphing inequalities day 2. Okay, so yesterday we did example 1. We talked about a lot of the definitions, and today we're going to get started with example 2. Okay, wrote down some of the rules from yesterday, and so let's get started. So example 2, we want to solve the systems of inequalities by graphing, right? So the first thing we're going to do is we're going to identify our M and our B, right? And actually, you know what? I want to change something up. I did remember this. I want to change something up. Before we get to this point, what if I was given the equation that looks like this? And I just want to do this so that you have a nice, good example of this. What if I had something like, give me a second, right? Let me do this pause. On your papers, you can kind of ignore that one right here. I'm going to give you another equation, an inequality that we're going to start off with. We're going to start off with this one right here. Negative 6x minus 2y is less than negative 2, okay? So we're going to use this inequality, and then we're going to be using this one, okay? So I can't do this as is. I definitely have to get it into slope-intercept form. So if you don't remember, the 2 steps to go from standard to slope-intercept is 1 to move x, and then 2, that's number 1. Number 2 is to divide by the coefficient of y, right? You know what? I wanted to keep it kind of similar, so don't worry about that one. Okay, so yeah, it's gonna be just, okay, coefficient of y. So what I want to do here, we're going to move x, and we move it by adding 6x and adding 6x. Are we okay with this? Okay. So that will zero out, and we're left with negative 2y less than or equal to 6x minus 2. Okay? And then the last step is that we want to divide by negative 2. Does anybody happen to remember when you are multiplying or dividing by a negative number with an inequality, what do you have to do? It's been a while.
Flip the sign.
There you go. Thank you, sir. So absolutely, you have to, when you multiply, or divide by a negative number, you must, I'm going to pretend that this says must, you must flip the inequality. Okay. So I'm going to go ahead, and when I reduce that, that ends up being y. I'm going to flip it so it's pointing the other way. Ooh, wait, that's not what I wanted. Hold on. My bad. Okay. So I'm going to go ahead and I'm flip it, pointing the other way. I've got negative 3 and positive 1. Okay. Notice how it kind of ended up with that. But I just wanted to show you, if you were given something in standard form, how you would get it into slope-intercept form, okay? So just a little refresher. So we have this, we have m is equal to negative 3, right? And then we have b is equal to 1. And so that means I'm going to start where b is 1 right here. I'm going to use my slope. Remember from yesterday, we had negative 3. We put it over a 1. And that means that we're going down and to the right. So I'm going to go down 3, 1, 2, 3, and to the right by 1. Down 3 and to the right by 1. Down 3 and to the right by 1. Okay. Now you could totally reverse it. And basically you're going up and to the left. I'm just squeezing it in there, but you get the idea. And if you're doing it right, you should end up with a straight line. So we're going to go up by 3, 1, 2, 3, into left by 1. 1, 2, 3, into the left by 1. 1, 2, 3, into left by 1. All right, ladies and gentlemen, I have a greater than or equal to sign. So I want to know two things in the chat. Is it going to be solid or dashed? Solid or dashed? And then tell me if I'm going to shade up or shade down. I'll give a little opportunity for everybody to answer. All right, so those of you who said it's a solid line, absolutely, because it does have a line underneath the inequality. And those of you who said that we shade up are absolutely correct. Now, Samantha, you were talking about something like you felt like it didn't matter. So talk to me about that. So I start here and I shade up. So why are you saying that it doesn't matter which way I shade?
I thought you meant like drawing the line shade.
Oh, no, I mean like where I'm going to kind of color. Yeah, because if you don't shade in the right place, you don't know where the solution is. So does that make more sense?
Yeah.
Okay, so here we go with this. Now I'm going to give y'all I want y'all to do this second equation right here. The y is less than or equal to negative 3x minus 2. Go ahead and do that. If you're watching this video, go ahead and hit pause. And I'm going to give y'all a minute head start. And then I'll kind of catch up with you guys. Okay. So 1 minute, here we go. Questions, should probably record this. So some of the questions was like, what was this one about? I really wanted to kind of show you how to go from standard form into slope-intercept form, just because you're going to be assessed on that. But they were nice and they gave it to you in slope-intercept form. So when of course you're identifying M and B and you begin to graph, it really must be in slope-intercept form, okay? So I said I was going to give y'all like a minute head start. Let me go ahead and get in there. And I'm going to do this one right here. So my M is negative 3. That's the same as the other one, right? Where we put it over 1. And that's down by 3 and to the right by 1. And then I got a B at negative 2. So let me kind of scroll down just a bit. And I'm going to start off at negative 2. And I'm going to go down by 3 and to the right by 1. Down by 3 and to the right by 1. And again, I put it in reverse, up by 3 and to the left by 1.
So they're going to be parallel.
Yes, they are parallel. Now, how could I have been able to tell that even without graphing?
They have same slope, different y-intercepts.
Yep, same slope, different y-intercepts. And Sophia, to answer your question, we write it in slope-intercept form? Yes, if it's not in slope-intercept form, you must write it in slope-intercept form. But this equation that they gave us here is already in slope-intercept form, okay? So I have less than or equal to. It's got a line underneath it. And I'm going to go ahead here and draw a nice solid line. Which way should I shade? Yeah. Yeah, basically it, Roman. You got it. So he said, notice how we're shading, right? We're shading down because this right here, remember our rules, like if it's like this, less than or equal to, we shade down because we can make a D out of it. And then here if it's greater than or equal to, we can make a P, so we can shade up. So this one is less than or equal to, so we can make a D out of it and shade down. We start at the y-intercept and we shade down. And so remember we said solutions live where the shading is overlapping. And Roman had mentioned, it's not up. Do you see why? Let me show you. So this is like important. Don't eyeball this stuff because your eyeballs will lie to you. So if I have this inequality right here, right, I can make a D out of it for down. See how that works? So you would shade down. So yeah, there's no overlapping area, right? So if there's no overlapping, and we said solutions live in the overlapping shaded area, if there's no overlap, then there's no solution.
So I confused myself again. When you say shade down, does that mean like shade on the left side?
Oh, when we're talking about, Okay, the best way to kind of keep it straight, and a lot of people kind of have this issue, right, is that you want to start at the y-intercept, right? And then from there, you just say, am I going to shade up or am I going to shade down? If I'm shading down, I'm going to go below and then shade that side. Does that kind of help a little bit?
Oh, that's what you mean by shading.
These little dots are my weak attempt at trying to shade.
So I was like, why are you shading if you're just going to be on the same side? But I get what you mean by up or down.
And then right here, I start at the y-intercept for the green one, right? And then I had to like shade up because this one is like that and we make a P out of it. So shading up. And I start off at the y-intercept and I go up and I shade on that side.
That makes more sense. Thank you.
Okay. So now the next one's really going to bother you because I wanted to show you what happens when we have special cases. Okay. So any questions on this? All right. Let's go ahead and let's talk about the next one. So here, this is a word problem. We have college service organization that requires its members to maintain at least a 3.0 GPA, grade point average, and volunteer at least 10 hours a week. Okay, so here's my little spiel. Number one, just out of curiosity, y'all know when y'all know what a GPA is, right? Grade point average. Do you know when your GPA for high school begins? Do you know when it begins?
I'm just gonna guess 8th grade.
Actually, it begins your very first day as a freshman at Marshall. Yeah, your freshman year. Okay? There's no do-overs. So you could think about it. Your next do-over will be, so as a freshman at a university, right? That would be the first day for your university GPA. But you do have a high school GPA and it starts your very first day as a freshman, as when you walk in the door, okay? And so when you're applying for colleges and whatnot, that's going to be something that information you're going to be submitting to them. And a lot of universities and colleges are interested in also knowing that you have interests outside of academia, right? They want to know about sometimes they want to know about community service and what do you do? So here we have this situation, and this one is an organization that's already in college. And in order to be in this organization, you have to have a 3.0. So most scales, and it could be slightly different depending on the school, and I could be lying to you because I'm going based on the information that I have. I believe like an A is usually a 4.0, right? And a B is like a 3.0, just to kind of give you kind of idea about it. And then does anybody know typically, and again, I could be lying, so hopefully I'm right. If you take a pre-AP class, how many additional, how much extra do you get for your GPA? Anybody know? 0.5. Excellent. Okay. Yeah, you get 0.5. So kind of keep that in mind as we're going into this question here. Okay. Now, so let's go ahead and let's look at this. So this first, right here, this is actually an inequality. This phrase that says at least a 3.0 grade point average. So I'm going to go ahead and tell you, well, let's go ahead and make X equal to your GPA. That stands for your grade point average. Okay. So if you would, let's see how many people can get this the first time around. In your chat, go ahead and tell me, type in what is the inequality that represents this little yellow phrase. Now keep in mind, if you wanted to type in less than or equal to, that would look like this. If you want to type in greater than or equal to, that would look like this right there, okay? And so I'm looking for three things. I'm looking for a variable, I'm looking for an inequality, and I'm looking for a number. Okay. So congratulations, all of you who said X is greater than or equal to either 3 or 3.0, doesn't really matter, okay? So I'm so glad that you remembered that at least, although it's counterintuitive, it kind of goes against what we would think because you see the word less in there, you just got to memorize that at least is going to mean greater than or equal to. That's one of those things you gotta know, okay? So keep that in mind. At least is greater than or equal to. All right, so knowing that, and I want to hear from more people that I didn't hear from before, I'm going to go ahead here and do this in green. I got another little sentence here that says, volunteer at least 10 hours a week. And I'm going to make Y is going to equal the volunteer hours a week. Okay, so go ahead real quick, type in that inequality. All right, very nice. Y'all got it. Y is greater than 10. Now, these are very special type of equations. Does anybody remember what kind of equations are these? They're kind of not your standard form, right? Anybody know?
I forgot.
You forgot? Okay. Tell me about Hoy-Bucks. What do you know about Hoy-Bucks? So these are equations that normally, like when we're talking about equations, it would be like y is equal to 10 and x is equal to 3. These are special cases. There we go. H is for horizontal. Is that ringing a bell? V is for vertical. If you don't know this, write it down, y'all. Okay? Yay, Anaya. Good job. Tell me about some slopes. What does this stand for, those two things? Or I'll tell you the slope story again, the slope dude. Oh, y'all don't want to hear that again. All right, this one is for zero slope, right? And this is actually a U. I don't know if you can tell. What does the U stand for? Very nice. Undefined. Okay, that's the where he like falls to his death. Remember that? Zero fun, falls to his death, undefined, yeah. So these are those like lines that are like straight that kind of go like this, or they go like, I'm trying to make my like arms, so they go like that, one of the two, right? Like this or like that. And so we just do that. And so these are actually like y-intercepts also, so that makes it easy. Let's go ahead and let's graph. That's x is going to be at 3.0. So I'm going to go to the x-axis. Let me do it in red. Do my little red. Here, we'll make it Christmassy. And I got x right here, and then I have it x is equal to 1, 2, and 3. Okay. Again, we have a line that is solid, right? It is an x equals line, so it is vertical, meaning goes up and down like the little L, right? Up and down. And it is undefined, so we're looking at a nice solid line going straight up and down. And I'm going to pretend I can draw a straight line. Okay. Now, normally I would say, hey, look at your inequality. And then can you make, look, we can make a P out of it. And we're going to shade up. And this is the part I was talking to you earlier about, where it's like, well, how do you shade up here? So just kind of go back to middle school when we're talking, when we have this one special line like this, where are all the numbers that are greater than 3 live to? Does that make sense? Where are all the numbers that are greater than 3 live? Do they live on the left of the line or the right of the line? Go ahead and put it in the chat. Or just on the line. Which way do we want to shade? Is that pink? No, it's more of a beige. All right. So let's look at our number line. Look, there's 5, yes? Is 5 greater than 3? Uh-huh. So it not only includes all the values at 3, but it's also including all the values that are bigger than 3. And so it's going to look like this, everything on the right. Are we okay with this? You're tripping. Is it the colors I'm using, Roman? Is that why you're tripping? Or is it, does it make sense? Yeah, makes sense? Okay.
It's not the same graph again.
Okay, next time, ma'am, next time. All right, now we're going to go ahead and do the green. Actually, I'm going to pause it right now, and y'all do the green one, okay? I'll give you about like a minute head start, okay? Go ahead and go. All right, so basically, here we go. I'm going to go ahead, and we are at 10. We have a y-intercept at 10. We're going to go to the y-axis. And I'm going to go ahead and draw a dot right there. Let's say, you know what? I'm going to make this 10. I'm going to redo my graph. I'm going to make it 10, right? That's 10. I have declared it as such. And we're going to go ahead here. It's actually 9, but I'm going to make it 10. Straight line going straight across. You know what? That's going to bug me. I'm sorry. I know somebody's like, okay. So this is actually 10. 5, 6, 7, 8, 9, 10. Okay. I got to do it right. Okay. And we know that our inequality is greater than or equal to, so we can make a P out of that. That's for up. So I'm going to shade up. And so I just shade up. Okay. And I'm also going to extend my little red line. Like so. And I'm going to extend my shading. Okay. So the next thing I want you to tell me is, a college service organization requires that its members maintain at least a 3.0 GPA and volunteer at least 10 hours a week. Please name one possible solution and put it as a coordinate pair, okay? As a coordinate pair. And so I'm going to change one word in there. I want to make this not possible, but reasonable. You hear this a lot. What is a reasonable solution, especially when it comes to word problems, right? Because mathematically, you can have one thing and it's logical and it fits, but from a reasonable, like we live in the real world, it doesn't necessarily always apply. So go ahead in the chat, tell me what a reasonable solution is. And well, we'll look into that one. So just to let you know, I do tutoring Tuesdays and Thursdays, 11:50 to like 12:20. The link is on my welcome slide. Okay.
I can't find it. Is it on the little slideshow?
I can show y'all. I'll show you right after. Yeah, it is. It's actually on the slideshow. So you look for the one with my face, and then click on. Okay. Yeah. And then I'm also kind of particular. Like if nobody shows up for the first 10 minutes, then I'm out. So make sure you're there. All right. And I also recommend that if you ever come for tutoring, that you come with like questions already ready, or maybe something where you watched the video, you took the notes, and you did the first attempt, and you did horrible, and you want to talk about it. That's a really good one to do. Okay. All right. So let me look at some of y'all's solutions. Okay. I got some good, interesting ones. I like that. Okay. I have one solution at 310. So 1, 2, 3, and 10. All right, so it's on a solid red line. Did it satisfy that first condition, the red one where your GPA has to be 3.0? Yes, okay. Does it, it's right there, like on the 10, and it is satisfying the green condition, right? Because it's on a green solid line. And so basically we're looking, when we look at this, this is 3.0 as a GPA. With 10 community hours. Now that means if they fail one test, they're out of the organization, right? Or if they, you know, forget to show up for one time, they're out. So they're in, but they're barely in, okay? That's for GPA and, that don't look like GPA, but GPA and hours. All right, let me look at another one. 611, 611. So that's gonna be 0 all the way to 6 and then 11 up here. Now, wait, is that's 5? Let me scoot it over. 6. Now, based on our conversation before, would you consider that reasonable? A reasonable solution? 6, 11. Because one number I think is reasonable, another one isn't. Michaela, you have a thought? Which number is reasonable? The 11 hours or the 6 GPA? The 6? So remember, do y'all remember what we said an A was?
Oh.
Yeah, and A's a 4.0, right? And maybe you can get like half a point added on for your GPA. They probably won't do that at the university level, but I'm just saying. So you're probably like, depending on the scale of the school, you're looking at like up to 4.0. So this may not be reasonable. Like, I don't know anybody at Marshall that has a 6.0, right? Okay. So although it's mathematically true, this I would say may not be reasonable. So I'm going to put not reasonable, even though it is mathematically true. The 11 hours is no problem, right? And let me look at one other one. I had 510. So again, we go to 5. They have a 5.0 and they're at 10. So again, I might question, can you have a 5.0? Some universities might have a different scale, and the 10 hours is no problem, right? Questions, comments, tears. You know what? I just realized this point. Did I put that? Oh my goodness. This point right here. This point. I'm getting myself confused. This is 310. Okay. Now I'm happy. This is 510 and then that's 611. Okay, got it. All right. Any questions, guys? Okay, so I'm going to put my reasonable solutions. I'm going to put the most reasonable solutions actually 310 here. Okay. All right. By the way, on the challenge questions, if you ever do them on your own and you want to talk about it with me, please feel free to. I'm going to go ahead and stop the video and I'm going to show y'all where the tutoring link is just in case. Okay. So those of you in video land, thank you so much. Click here to subscribe. No, I'm just playing. Bye, y'all. All right. And stop. Yay. Yes, I want to stop.